again, can you hear me? Can you hear my voice?
Yes, sir.
Yes, sir.
So this meeting, by the way, we're going to discuss, well, this one is still the introduction, no, about the matrix structural analysis or the matrix analysis of structures. No? Ako na siyang gi-attach ni siya sa modules ninyo last week. Okay, so I hope na kabasa-basa mo ni gamay. No? Okay, so again, this is still about the introduction, no, about our kanang subject, the matrix structural analysis. No? So when we say structural analysis, by the way, are you done with kanang theory of structures? Manaman mo tanan, di ba? Guys?
Yes, sir.
Yes, sir.
Unsa na mo nga grade karon? 4th year?
Yes, sir.
Okay, so ang civil engineering karon 5 years gapon despite nga nanay K-12.
Kutob na lang first sem sa 5th year, sir, OJT.
5 years gapon?
4.5, sir.
4.5. Okay. Okay, so I believe you already have an idea about this one, no? Kuning structural analysis. So when you say structural analysis, it is an integral part of any structural engineering project. No? So this is the process of predicting the performance of a given structure under a prescribed loading condition. This one involves the determination of the stresses, okay, like the axial forces, shears, and bending moments, no? As well as deflections, as well as the support reactions caused by the given loads, no, and or other external effects. No? So before we can design a structure, so we need to analyze it first. We need to determine the stresses, no, developed on the members caused by the applied loads, no. So whether it's a dead load or live load or environmental loads like earthquakes and wind loads. Okay? So, for example, na kay beam, okay, let's say simply supported beam, no? So, we have pin on one side and let's say a roller on the other side. No? Okay, so let us say this is subjected by a force P, a concentrated load, for example. Okay, let's say this one is a distance of 2 meters and this one is 3 meters. So the span of the beam is 5 meters. No? So basically the process, okay, of finding the reactions here, okay, the stresses on the beams, no, like the shear, this is a beam, so it is subjected to shear and bending, no? Okay. So, well, this is simply supported, so it's not a problem to analyze this one. You can simply analyze this using the equilibrium equations. No? Like you sum up the moment here, equate that to 0, you can solve the reactions here. Okay. And summing up forces vertical, you can also solve the reaction here. No? So once you have the reactions, then you can draw the shear and moment diagram. So basically, you can determine the maximum shear and bending or flexural stresses developed in the beam. So the process is again what we call as the structural analysis. This is not a problem because this is just simply supported beam. So it is a determinate structure. Okay. But it becomes quite complex if you consider, let's say, the entire building, for example. So it's three-dimensional. So normally, to do the structural analysis, we are going to use software. So there are now many screen?
Yes, sir.
Guys? Sige, so balik ta, no? Katong structural analysis. So it is one na siya, murag part of the process gina siya na when you design structures. So you need to ginanglang kag shear, moment, no? Axial loads, no? Or axial stresses. Of course, kinanglan po to you check the deflections, no? So that's specifically important when you're dealing with mga long span structures, no? So long span beam or even trusses, no? Okay, and also kanang structural analysis that is also useful to check if your structure is stable or not. Okay? Or ang iyang performance po if there is mga earthquakes, no? So that's pretty important, no? Okay, now we have here the classical versus the matrix methods, no? So what you have learned so far is katong mga classical method, no, of doing structural analysis, no? So sa inyong theory of structures, no, kung na kay mga indeterminate beams, for example, no, so you have the area moment method, no, the double integration method, virtual work method, no, and so on and so forth, no. So yung moment equations, no? So those are structural analysis po, no, but they are considered under the classical approach or classical method. So both matrix and classical methods are based on basically the same fundamental principles. No? For the matrix method, fundamental relationships of equilibrium, compatibility, and member stiffness are now expressed in the forms of matrix equations so that the numerical computations can be efficiently performed on a computer. So kaning matrix method, no? Although based ra gyapon siya sa principle sa basically the same principle with the classical methods, no? Pero ang diferensya lang ani niya, ang sa matrix method gi-express na nato, no, in terms of matrices, no? So ang mga relationships sa equilibrium, no, compatibility, as well as the member stiffness, no? So they are now in matrix forms. So basically, ang purpose kaya niya para ma-program nato sa computer, no? Okay? So kaning matrix method, this is not intended for manual calculations, no? So this is really intended for computer programming. So mas dali man siya i-program kung naka-matrix siya, no? Okay? Rather than using the classical approach nga daghan kayog mga variations, no? Whereas if it's a matrix method, so ano siya, uniform ang iyang approach. Okay? So again, the purpose of this is just to program, no, the computer. So kanang mga computer programs na to, no, na mo analyze of structures, so definitely they are using the matrix methods. Okay? So most classical methods were developed to analyze particular types of structures, and since they were intended for hand calculations, okay, so they often involve certain assumptions that are actually unnecessary, no, in matrix methods, no, and that is to reduce the amount of computational effort required for the analysis. Now, for matrix methods, this one again, as emphasized a while ago, no, matrix methods were specifically developed for computer implementation or computer programming. So they are very systematic, no? And they can be easily programmed, no? In using the different programming language, no? Like C++ or even Visual Basic, no? Okay? MathCAD, no? So on and so forth. And in general, in the sense that the same overall format of the analytical procedure can be applied to the various types of frame structures. Okay? Now let us compare this matrix method, the finite element method. No? Okay, I am pretty sure all of you are also have heard also this type of method analysis, the finite element. No? So matrix methods can be used to analyze frame structures only. So that's the limitations for matrix method. No? So it is only limited up to frame structures. No? So on some frame structures, later on I'm going to expand that one. No? Expand that one. So finite element analysis, okay, or if FEA or FEM, no, finite element method, which actually originated as an extension of matrix analysis to surface structures, so katong mga plates and shells, no? Okay, has now developed to the extent that it can be applied to structures and solids of practically any shape or form. Okay, so kaning finite element method, so nag-originate ra gyapon ni sa matrix method of analysis, no? Okay. Okay, so this is practically applicable to any structures, no? Solids of practically any shape or form. This is particularly applicable to plates and shell, no? So, example, mga labs, okay? Or mga walls. So, kaning finite element method mo imong gamiton. Now, in matrix methods, the member force displacement relationships are based on the exact solutions of the underlying differential equations. Okay, so I believe manaman mo mga differential equations, no? Or advanced engineering mathematics. Okay, so kaning member force displacement relationship, okay, force to displacement, no? So normally this is based on the exact solutions of the underlying differential equations. So but we have to express this in matrix forms and we can solve this numerically. In finite element method, the member force displacement relationships are generally derived by the work energy principles from assumed displacement or stress functions. Okay, the finite element analysis generally yields approximate results. No? So, kaning finite element method, this is a numerical approach. No? So, ang iyang results ani is not that accurate. No? So, approximate na siya. So, I think when you take up master's degree, no, in structural engineering, to which we offer, no, in the University of San Carlos, no? So, one of the subjects is the finite element analysis or the finite element method. Okay, so let's proceed. No? So we have here the flexibility and stiffness methods. Actually, sa matrix structural analysis, there are two methods. No? So kaning flexibility method, the other one is stiffness method. No? So ang atong gigamit diri is kaning stiffness method. No? So I'm going to explain that later on. No? So the flexibility method, which is also referred to as the force or compatibility method, is essentially a generalization in matrix form of the classical method of consistent deformations. No? So mura ra gyapon siya classical method ni siya consistent deformations unya gi-express lang in matrix form. So kana mo na ang flexibility method. No? So in this approach, the primary unknowns are the redundant forces, which are calculated first by solving the structure's compatibility equations. Once the redundant forces are known, then that's the time we solve or evaluate the displacements, no? By applying the equations of equilibrium as well as the appropriate member force displacement relations. Okay, that's for the compatibility method, no? Or flexibility method. Whereas the stiffness method, which originates from the classical slope deflection method, no? Okay, I hope nagianin ninyo ang slope deflection method, no, sa theory of structures, no? Okay, this is also called the displacement or equilibrium method. Okay, so in this approach, Okay, I'm referring to the stiffness method. No? So the approach here is that the primary unknowns are the joint displacements. Okay, ang unknowns na to ang displacements. No? Unlike sa flexibility method, ang unknown na to ang mga forces, mga redundant forces. No? So sa stiffness method, ang mga unknowns na to is ang mga displacements, no? Which are determined first by solving the structure's equations of equilibrium. With the joint displacements known, so once you have the joint displacements, the known forces are now obtained through the compatibility considerations as well as the member force displacement relations or relationships. So again, ang stiffness method, ang unknowns ang mga deflections. Okay? So once you have the deflections, then that's the time you compute the forces. Okay? Yeah, mas ayon siya, no? Mas direkta ganing stiffness method, no? The stiffness method, actually, this is more systematic, no? This is more systematic and can be implemented more easily on computers. So therefore, it is preferred for the analysis of large and highly redundant structures. Okay? So most of the commercially available software for structural analysis is based on the stiffness method. Okay? So mas systematic ang stiffness method, no, compared to the flexibility method. Okay, now let's go to the classifications of frame structures. Remember, ang matrix structural analysis is only limited to frame structures. Okay? So, sa man yung mga frame structures. No? Frame structures are composed of straight members whose lengths are significantly larger than their cross-sectional dimensions. Okay? So, ang iyang gitason, mas significantly larger, no? Mas dako kaysa iyang cross-sectional dimensions. No? Common frame structures can be classified into 6 basic categories based on the arrangement of the members and the types of primary stresses that may develop in their major design loads. Okay, so kaning frame structures can be classified into 6 categories. No? So, sa man yung mga categories karon. Plain trusses, that's one. No? So a truss is defined as an assemblage of straight members connected to their ends by flexible connections and subjected to loads and reactions only at the joints. No? So that's the assumptions for an ideal truss. No? So the loads are applied at the joints. No? So the reactions are also at the joints. Okay? The members of such an ideal truss develop only axial forces when the truss is loaded. Okay? So one of the basic assumptions of the truss is that it's a two-force member. No? So it's only it will only develop axial forces, no? Or axial stresses. No? If all the members of a truss as well as the applied loads lie in a single plane, well, the truss is called a plane truss. Okay? So two-dimensional truss. No? Kana, for example, ana lang, lie in a plane. So this is an example of a truss. So, may mga loads na din no? Mga reactions po na sa mga joints. Okay? So ang kaning member, for example, so it's a two-force member. It's either in tension or in compression. Axial load, drag it siya. Okay? So that's one. So this is the example, no, of a plane truss, no. So connected by frictionless hinges, no. Okay. Next is beams. So a beam is defined as a long straight structure that is loaded perpendicular to its axis. So the load should be perpendicular to the longitudinal axis. No? Loads are usually applied on a plane of symmetry of the beam's cross-section, causing its members to be subject are also referred to as rigid frames. Okay? And this one is composed of straight members connected by rigid or moment-resisting connections. No? Okay? Unlike trusses, frames are subjected to external loads only at the joints. No? No. Unlike trusses, in which the members of the truss is connected at the loads are only applied at the joints. No? So for frames, the loads may be applied on the joints as well as on the members. Okay? Necessary that the loads are applied at the joints. No? If all the members of a frame and the applied loads lie in a single plane, well, the frame is called a plane frame or a 2D frame. Okay? So 2D truss, okay, if it's a truss that lie in a single plane, so that's a 2D truss. No? If it's a frame, that's a 2D frame. To distinguish this from the three-dimensional frames. No? So this example of okay. Space trusses or 3D trusses, three-dimensional trusses. No, another term for that is space trusses. So some trusses such as lattice domes, transmission towers, and certain aerospace structures, no, na kanang mag-design ka o mga billboards, no, mga transmission towers, communication towers, no, or domes, no. So the appropriate type of analysis for that is you analyze that using a three-dimensional truss, no, versus space truss. No? So we cannot treat that as plain truss anymore, no? So because of the arrangement of the members, no? And also the loads. So such trusses are referred to as space trusses, are analyzed as three-dimensional structures subjected to three-dimensional force systems. No? So like plain trusses, the members of space trusses develop only axial forces. Okay, so ang loads gyapon gi-apply nimo sa joints, no? Only that you treat this as three-dimensional. That's the difference between a 2D and a 3D truss. So mo na yung mga examples sa guys, madungog na ko? Hello?
Yes, sir.
So, asa na ta? Grids, no? So, kaning grids, for those who are not familiar, so mura ragya po ni siya o frame, pero instead nga pa vertical, pa horizontal lang. So, a good example of this is kaning floor system, no? So, kani. Okay, so grids are commonly used for supporting roofs, covering large column-free areas in such structures such as sports arenas, auditoriums, and aircraft hangars. So, mura ni siya o diaphragm. Okay, so ang grid na ay moment, na ay shear, then you also have torsion as additional type of stress. Then the last one is kaning space frames or 3D frames. So when you analyze, when you practice structural engineering later on, no, so gamit man ka, since mugamit ka og mga programs yun, so ang treatment kini mo normally is to treat, for example, mga building structures as three-dimensional frame. Okay? So 3D ang imong analysis. So mas accurate siya. No? Okay? So space frames constitute the most general category of frame structures. Okay? So actually, pwede tanan type of structure kaya kuha nimo, assume nimo as space frame kita na, no? Okay, for practical purposes. Members of space frames may be arranged in any arbitrary directions and connected by rigid and flexible connections. Loads in any directions may be applied on members as well as on joints. So kaning frame member, a space frame member, so nana kay axial load, shear, moment, and torsion. Okay? So kompleto na ni tanan. No? So muna mag-design ka na mukuha kang member, so na kay mga you design it in such a way nga it can naputol ba ko sa space frames na part? Hello? Hello?
Yes, sir.
So nahuman na to katong space frames?
Yes, sir. Nauman na, sir.
Sige. So again, there are kanang sa atong matrix analysis methods, no? So limited raman siya to frame structures, no? So kanang mga 2D trusses, 3D trusses, 2D frame, 3D frames, no? Beams, and also grids. Okay? So basically mo na atong mga ipang-discuss on how to analyze, no? Starting from the very basic one-dimensional rod, no, to 2D trusses, then up to the more complex, the three-dimensional frames. Okay, so ang kaning one actually matrix analysis, no, so pretty simple kay as pointed earlier, no, one naman siya, very systematic siya, no. Okay, so ang proseso is maura gina siya, no? Although mag-anam lang og daghan ng imong ma-involve na mga matrices. Okay? But again, ang main objective ra gid ani is para sa computer programming. Okay? So this can be easily put into computer programming. So later on sa inyong mga assignments, so mugamit mo og kuana, no? Kanang maybe minimum Excel, no? So if you're familiar with other programming languages, then well and good. MathCAD, you can use MathCAD also, or even C++. Do you have questions or clarification so far? So pasensya kayo kay ang internet sa balay, kuan lang gyapon, no? Kanang problematic lang gyapon. Although amo na din siya gipa-upgrade, no? Ang pinaka-highest. But still, lagi ako yung problema. No? Maybe next meeting, I'm going to try ito sa office na set. No? Hopefully, okay ang internet connection po dito. Extender sa Wi-Fi. Oh, actually, may kuan dire kanang mga extenders dire, no?
Kuan sir, I think mo na siya ang issue sa bag-o nga mga 5Gs karon kay if layo ka sa router sir kay murag hinay siya then kusugra siya if duol ka sa router.
Actually, na ay mga kuan rin. In fact, dual ko sa router gani. Pero extender na siya. Niligid ka tong main na router naman sa ubos. So sahay maputol. My initial plan was actually to discuss kanang one-dimensional analysis of one-dimensional bars karon, no? Pero nagsige magutag ka putol-putol po, no? And it's already 11:30, so I'll just discuss that this coming Friday na lang, no? Friday. Okay, so I hope naka-submit na mo sa inyong mga assignments, no? Okay. By the way, naaba to dari ang katong mga nag-take up og masters? Tulong mo ito ko buhok? Hello?
Sir. Hello, sir.
Sir.
Yes. Okay. That's good. Nagkuhan ko kuhan ninyo kanang katong mga requirements na lang ninyo. Akong gi-post sa Canvas. So na dito ang inyong mga assignments, no? So separate ang inyong assignments sa undergrad. So akong gipabuhat is katong magkuhan lang mo mga lecture slides, no, for the katong 6 topics, no. So pag-analyze sa body trust, no, para po nahan mo tudlo. So at least ready na ang inyong lecture slides. So kaning inyong pag-attend diri, so optional lang ni, no? So hello?
Hello, sir.
Yeah. So you didn't need to submit the katong mga assignments na intended for the undergrad, no? So you have a separate kuan katong assignments or requirements, no? Sa masters. Okay, so any questions or clarifications? Woo!
None na so far sir.
Nahadi ay kuan kaning upcoming webinar, no, nga gi-organize namo sa ASEP, no, including the PICE here in Cebu. This coming October 15 and 16. It's about the design of reinforced concrete structures. Okay, so those who are interested, I think it's 800 pesos man siguro, no, ang fee na. It's a 2-day webinar. So those who would like to get some insights about how to design reinforced concrete structures according to the requirements of the code, so nindot sa na siya, no? Okay. So pwede ra mo search sa ASEP na website or ASEP na page, no, Facebook page, as well as PICE Cebu chapter, no, Facebook page. Okay. Currently, I'm the the president of the PICE Cebu chapter, and also the one of the directors sa ASEP, no? ASEP stands for Association of Structural Engineers of the Philippines. Okay, so kung practice mo nindot mo sa ning quite fulfilling po, no, kung maka-design kag mga structures. So dili lang may buwan panahon, no? So fourth year naman mo karon, no? So maybe 1 year na lang siguro take na mo board, no? Kay 4.5 years naman ka ang CEE ron. So once you pass the board exam, so wala ka nang that's your ticket to practice structural engineering. Sa ato, sa current nga balaod nato, so if you are a licensed civil engineer, you can already practice, no? So any of the specializations under civil engineering, and that includes structural. No? So, you know, civil engineering is a broad profession. There are many specializations, no? Okay, or subfields under civil engineering. So structural is one. We have construction, geotechnical engineering. So kaning mag study of mga soil, no? We have water engineering. So si Engineer Fornes is an expert, no? So water, then kaning highway, no? Transportation engineering, no? So highway engineering. So that's also one. So in fact, ang PIC nag-identify sa 6 areas of specialization. So katong 5 nga akong i-mention, the last one is kaning environmental, no? And energy. So basta licensed civil engineer na ka, pwede na ka maka-design. No? Okay, so that's also how lenient our law is, no? So ang balaod nato. So unlike in other countries nga pa kay mga additional kuhansad, mga you don't need nga mag-masters ka nga magka-design na ka, no? So kuha na siya. Ang sa balaod na to, basta license na ka, pwede na ka mo-practice. So as simple as that. Okay. But of course, so once na naka-experience, so mas may magpa-member na sa ka mga like sa ASEP, no? So at least ma-recognize na ka as you have every right nga pwede na ka mo tawag as a structural engineer. Kaya evaluate naman ka that you have met the minimum requirements as a structural engineer. Okay? Do you have questions?
Excuse me, sir.
Yes.
Regarding sa masteral, sir, kay among nakitaan kay assignment ra gihapon pareha sa undergrad, sir.
Di, na ko upload last night. So, kuhan to ka ng new set of assignments.
Basig wala kanang open to students man siguro ng term anang sa Canvas, sir. Di pod ko sure. Yo dili na mo.
Sige. Ako lang to, i-check lang to na ako ha. So, again, sa katong nag-take up of master, so na may separate requirements. No? Okay? Now, by the way, Kwan, I highly recommend nga you have to join the seminar siguro, webinar, no? Katong sa ASEP na organized webinar, no? Sa mga structural engineering. So we have this coming October 15 and 16.
Okay, sir.
Any questions? Ooh. Okay, so I think we have to end our session. So next Friday, so mag-discuss ta about the analysis of one-dimensional bars. For the meantime, wala tayo assignment, no? So this coming Friday, mahatag ko assignment. Okay, that's all. And have a pleasant morning and keep safe. No? God bless.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.